Okay, I'm having some technical difficulties with my pen, which is now deciding it only wants to work half the time. I'm going to try to keep going, but I can't make any promises. So here for this one, we've got this thing going in a circle, this ball going in a circle around a bowl at some angle theta up from straight down. So that's the velocity there. It's sort of going around, or the speed, sort of going around the circle. It's accelerating towards the middle. You have to imagine this is sort of like in this plane of motion. And then here is the radius of its circle. So this radius r is not the same. The little r is not the same as big R. Big R is the radius of the sphere, and you can imagine that this here must be big R, right? But little r is not the same as big R. So with all that in mind, first we want to look at the issue of what is this ball doing? What are the forces acting on the ball? Well, there's a normal force in the ball that's always acting towards the center of the sphere. So you can imagine here's like sort of a cross section of the sphere. There's a vertical, give or take a vertical, and the ball is like right there at some angle theta. Well, the normal force acting with the sphere on the ball is always going to be pointing in towards the middle, right? Meanwhile, the gravity of the ball always points down. So if we do a free body diagram for the ball, and I'm going to do a usual XY there, okay? FBD for the ball, goes X, Y, okay, and so here is our ball, there's our normal, theta, mg, okay, and so let's look at now, okay, so let's look at the components now. So up in cosine theta to the right, in sine theta, and down mg. So now let's see, now I think you guys have probably seen this 5 million times. This is just an object on a slope, or on a slope at some angle where we got a force going at some angle. You've seen this 5 million times, you know this is the same thing, but I'm just going to do it anyway real fast. Sum of forces in the y direction is 0, which means n cos theta equals mg, right? Mg, and so n equals mg over cosine theta, and then sum of forces in the x direction equals ma, right? Because it's accelerating to the right, accelerating, boom, 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 accelerating. Okay, so let's finish that off then. Sum of forces in the x direction is ma, which means n sine theta equals ma, which means mg sine theta over cosine theta equals ma, which means cancel the m's, of course, sine over cosine becomes tangent, and a equals g tangent theta. Okay, so easy enough, right? So a equals g tangent theta. What else is a equal to? A is equal to v squared over r. So anytime an object is going in a circle, the acceleration is v squared over r. So, and that equals g tangent theta. Now what we're given in the problem, we're asked to find a relationship between theta and the period. So usually the way we get there is the speed is the distance it travels in one circle divided by the time it takes, which is the period. So v is 2 pi over t, v squared 4 pi squared r squared over t. So this means 4 pi squared r squared over r t squared equals g tangent of theta. We go to purple, light purple, and you can take this r squared, cancel 1r against that. So then you got 4 pi squared r over t squared equals g tan theta. Now we also know that, let's go with sort of this interesting color. We also know that, well, so what's this r in terms of big R? Well, this angle theta here, this is really the angle theta, is this angle up here. So this is little r, and over big R is going to be the sine of theta, right? Adjacent over hypotenuse. So little r equals big R sine theta, which means then that if we pull these through, and let's page down a little, okay, so I pull this through 4 pi squared big R sine theta over t squared equals g tangent theta. Well, tangent theta, if you'll recall, is sine over cosine, which means this sine and this sine cancel, and basically we can push this cosine over, and then with a little rearranging, okay, we can get to come on, there we go. Okay, we can get to 4 pi squared r cosine theta over g equals t squared. Or we actually are the way it works in the example, or the values they give us, is they give us t and wants to find theta. So we can do actually cosine theta equals t squared g over 4 pi squared big R. Now, here's the thing. When I give you the numbers I gave you, I'll draw these over here. So given was big R equals 13.2 centimeters equals 0.132 meters, okay? And then t, I said, was 1.0 seconds, and then of course g, we're going to say, is 10 meters per second squared. And this tablet is starting to go freaky on me. I'm rather disappointed, actually, because I haven't had it for that long. But oh, wait a minute. Oh, I know what it was. I was hitting the mouse pad because I had it sort of propped up on the laptop. Oh, yeah, that's what it is. I was hitting the touchpad. No wonder it was misbehaving. Okay, well, good to know. Isn't it nice to be, listening to me online when I discover how stupid I was being when I thought the computer wasn't working? Yeah. Okay, so anyway, now that I am fully armed and operational, so here's the point. If we take these, this doesn't work, because 1.0 squared times g is going to be cosine theta equals 10 over 4 pi squared times 0.132. So it's going to be 10 divided by 4 is like 2.5, and then divide that by pi, divided by pi again. Pi squared, remember pi squared is almost equal to g, remember that? But we can say it's almost equal to 10 too. So really we can say 10 divided by this, which means you're going to have 1 over 4 times 0.132, which is going to equal 1 over, what's 4 times 0.132? It's like it's like, around the neighborhood of 0.5 or a little bit bigger. So approximately equal to 0.15, approximately equal to 2. What kind of angle has a cosine of 2? Well, I'll give you a hint. Theta has to be imaginary. Yeah, it's stuff that you guys haven't seen, like imaginary angles, and even with what I've been through, like the math classes I took in college and grad school, I don't actually even know what an imaginary angle means, okay? So the point is, this doesn't work. We know physically it certainly doesn't work. So this is our relationship here. I must have given us, something that just doesn't work. So let's find out what the limit is. What's the, the maximum, let's see. Let's find out what the maximum, what happens, okay, so let's just experiment with this. What happens if cosine theta equals 1? That means t squared g over 4 pi squared big R must equal 1, right? Now using the bowl of Stephanie's, my fiance, that's going to mean that t squared equals 4 pi squared big R over g, and R here is 0.132. So let's see, 4 times, I'm just still going to say pi squared is about 10. Okay, R is 0.132 meters, and then G is also going to be 10. So these cancel. 10 cancels. So 4 times 0.132 is going to be 0.528. So t squared equals 0.528. Well, okay, so that means, I don't know, maybe t is is around like 0.71 or 72, I guess. I mean, if t squared was 0.5, then t would be 0.707. So maybe we'll say like if it's 0.52, p is 0.72 seconds. So that's for cosine theta equals 1, but that would be theta equals 0, which is when it's right at the bottom. So that's weird. Okay, but let's look at the other extreme then, which is and you know, if you've lost interest in this, feel free to shut it off. You know, I'm just rambling at this point. But cosine theta equals 0 means theta equals 90 degrees. So this is when, you know, you got the whole bowl there, and this thing is practically right up on the rim. So this really represents sort of the highest up we can get it, right? So that means, but this is going to be freaky, right? Because t squared g equals, over 4 pi squared r equals 0. All that equals 0. So now this, you know, 4 pi squared is going to be, you know, I mean, we know these are all positive numbers, right? So there's nothing freaky going on down here. G is going to be positive, but so we know G, we know R, we know all these. Really what this means is that t squared has to equal 0, which means t has to equal 0. So, you know, I don't know. I mean, I guess this means any period between 0 and 0.72 is doable. Maybe? I don't know. Let's say what if t is 0.5 seconds. So I'm going to just go one more shot and say, you know, t equals 0.5 seconds. Huh? Does it work? Okay. So first I have to come up and get my actual formula. So let's see this one here. So let me just cut and paste that so I can copy, paste. All right. So put that in, and let's see. So let's do sure, cosine theta. If suppose t is half a second, fine. Cosine theta equals 0.5 seconds squared times 10 meters per second squared over 4 pi squared times 0.132 meters. Okay, and because I'm in a you know, a good mood right now, I guess I'll just go ahead and use the calculator and actually find real numbers as opposed to using like pi squared equals 10 and all that jazz. So let's do so we're going to do 0.5 squared times 10 divided by 4 times pi squared times 0.132, and that is going to give us 0.4797. So over this here, this equals 0.4797, which is, I mean, it's close to 0.5. So we're going to get around, what's the cosine, right? So we're going to around like 60 degrees, but let's just try it. Answer. And yeah, 61.3 degrees. So theta 61.3 degrees. So maybe maybe the version I get to 5th and 6th period tomorrow, I'll change the time to be 0.5 seconds, and then they'll actually get a decent number, assuming they can follow through all this, which, yeah, they can. Just take some time. Okay, well, anyway, there we go. Now you know about that problem.